Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is the chain rule. A special rule, the chain rule, exists for differentiating a function of another function. In this video, we are going to discuss about this rule. Here in this video, we are going to learn how to differentiate a function of a function. We first explain what is meant by this term, and then learn about the chain rule, which is the technique used to perform the differentiation. Consider the expression cos x square. Immediately we note that this is different from the straightforward cosine function cos x. We are finding the cosine of x square, not simply the cosine of x. We call such an expression a function of a function. Can you follow so far? A function within another function. Suppose, in general, we have two functions, f of x and g of x. Then, y equal to f of g of x. This is called a function of a function. In our case, the function f is the cosine function and the function g is the square function. We could identify them more mathematically by saying that f of x is cos x and g of x is x square. So that f of g of x is nothing but f of x square. I'm just plugging in the value of g of x here. After that, you have to plug in this value in the function f of x. So I'm replacing x by x square. Now let's have a look at another example. Suppose this time that f is the square function and g is the cosine function. That is, then y equal to f of g of x would be, first plug in g of x. So f of cos x, where f is x square. So this should be written as cos x the whole square. We often write cos x the whole square as cos square x. So cos square x is also a function of function. So in the following video, we learn how to differentiate such a function of function. Okay, here is where the chain rule is applicable. In order to differentiate a function of a function, y equal to f of g of x, that is, to find dy over dx, we need to do two things. First, we will be substituting u equal to g of x. So this will give us. Next, we need to use a formula that is known as the chain rule. Here is the formula. Dy over dx is nothing but dy over du times du over dt. This is the chain rule. So far we discussed what is a function of a function. Whenever you get function of a function, the rule that we are going to use for differentiation is dy over dx, which is the chain rule. Now let's see some examples and look into the formula and how it applies. Here is the first example. Suppose we want to differentiate y equal to cos x square. So for this function y equal to cos x square, let u equal to x square, so that y equal to cos u. So it follows immediately that du over dx is nothing but 2x. Same way, dy over du is negative sin u. Am I right? The chain rule says, so all we have to do is just plug in the values that we got in this formula. So dy by du is negative sin u. Du over dx is 2x. So by multiplying these, finally, you have to back substitute the value that we assumed for u. U is x square. So the final answer is. That's it for this example. So first you have to identify what is a function within another function. After identifying both the functions, you have to differentiate them. And finally you have to plug them in the chain rule. So you have to memorize this formula. It is easy to memorize too. Suppose we want to differentiate y equal to cos square x. Please compare this with the previous example. In previous example, we got a function y equal to cos x square. So that is completely different from this one. So this can be written as cos x the whole square. Am I right? You should look into the function keenly to identify what are the two functions. So you should know where the exponent is. So here cos x the whole square. So you can assume u equal to cos x, so that y equal to u square. Am I right? Which follows that we are going to find du over dx and dy over du. For dy over du, we are just going to apply power rule. So 2u raised to 2 minus 1, which is nothing but 2u. So here for du over dx, so derivative of cos x is nothing but negative sin x. Here is the chain rule. Just plug in the values you got in this chain rule. By multiplying, we'll get negative 2 times sine x. Okay, here you have to back substitute the u value too. Then you can write your final answer. We are just multiplying everything. So 2 is the coefficient and you bring the negative sign before the coefficient and just multiply these two trigonometric functions. That's it for this example. Now I'm going to take a polynomial as an example and explain you how to apply chain rule in that. Please look at this example. Now it might be tempting to say surely we could just multiply out the brackets. To multiply out the brackets would take a long time and there are lots of opportunities for making mistakes. So let us treat this as a function of a function. I'm going to assume the entire expression within the parenthesis as u. So u equal to 2x minus 5. So that y can be written as u raised to 10. Am I right? In mathematics, there are many ways to solve one single problem. You have to choose the method that is very convenient and which would make less number of steps so that you can save so much time. So here for this problem particularly we can use chain rule instead expanding it. So assuming the function of a function. So inner function is u and the outer function is rewritten based upon the u. Now we are going to apply the chain rule. We can find the du over dx and dy over du separately and then we will plug them in the formula. Du over dx is nothing but 2 because derivative of x is 1 and derivative of the constant is 0. So you need not mention the last term. So derivative of u is nothing but 2. Same way for derivative of dy. Dy over du, here we are just going to apply power over power rule. Power over power means you'll be shifting this exponent to the coefficient's place and subtract 1 from the exponent. So we are going to do the same thing here. So 10 u raised to 10 minus 1 is 9. So 10 u raised to 9. We have got both these separately. Now we are going to plug them in this formula, chain rule. Please make sure that you back substitute the value you assumed for u finally. So here if you're back substituting it, your final answer is going to be. That's it for this example. You'll get the same answer if you follow the other methods too. So this is how we deal with chain rule. Now we are going to see a simple technique for differentiating directly. So in this video we develop through examples a further result. Suppose we want to differentiate y equal to e raised to x cube. So let u equal to x cube so that y will be equal to e raised to u. Am I right? So by differentiating we will get du over dx and dy over du. Let me quote the formula again, chain rule. Now just plug in the values you got in the previous step in this formula. So we will get, now just multiply and please make sure you just back substitute the value you assume for u. So u has to be replaced by x cube in the final step. We will now explore how this relates to a general case, that is differentiating y equal to f of g of x. To differentiate y equal to f of g of x, we let u equal to g of x so that y equal to f of u. Am I right? And the chain rule states that dy over dx is equal to dy over du times du over dx. In what follows, it will be convenient to reverse the order of the terms of the right. So you can just rewrite it as dy over dx as dy over dx times du over dx times dy over du. So which in terms of f and g we can write it as. This gives us a simple technique which with some practice enables us to apply the chain rule directly. Please have a glance over this. You can compare it with the original chain rule formula. Then you'll get a clear idea about this. I'll give a small recap on the key point. Given function equal to f of g of x. Identify the functions f of u and g of x, where u equal to g of x here. Then step 2. Differentiate g and multiply by the derivative of f, where it is understood that the argument of f is u equal to g of x. Hope you are clear with this simple technique. Please consider this example. We are going to differentiate y equal to tan x square. So we apply these two stages. First I am going to identify f of u and g of x. Here f of u is tan u, because I am going to assume this inner function as u and g of x is the x square. Second step, differentiate g of x. So by differentiating we will get, after finding the differentiation, we are going to multiply by the derivative of fu. Derivative of fu is nothing but secant square u. Am I right? You can also refer the list of the formulas for differentiation. So which is secant square x? That will give you, by back substituting the value of u, you will get. That's it for this problem. So all you have to do is differentiate g and multiply by the derivative of f. That is called chain rule. Hope you are clear with chain rule now. In case if you have any query